Hi, I hope you guys are doing well. In the last video, we had been talking about redox reactions. We said can be redox reactions when we talked about the basics of it, and then we jumped to the concept of oxidation numbers. Rule number one was if it's an element, it is zero oxidation state. Rule number two was if it's an ion, the charge of the ion is the oxidation state. Rule number three was that if it's a compound, the compound has all the elements with their own oxidation states, but they total up to a zero. And then the fourth rule was if it's an ion, it's a polyatomic ion with multiple atoms and all, then each element has its own oxidation state, but the total doesn't add up to zero. The total adds up to the charge of the ion. ठीक है जी? In today's class, we're going to be talking about some kinds of various examples of whether oxidation is happening or redox is happening or reduction is happening, and then we'll jump to the balancing. So we're going to talk about some half equations using our understanding of redox reactions and obviously oxidation numbers. For example, there's a case where, for example, iron was FeCl2 and it turns into FeCl3. No, it's not a complete equation. I'm just saying this. Iron is with two Cl's, right? So when it was two chloride ions, the two chloride means minus 2. Minus 1, each chloride is minus 1, and there are two of them. So that becomes minus 2. Iron has to be plus 2 because iron ion is cancelling the minus 2 caused by the two chlorides. When I look at the product side, the product has chloride, but 3 of them. So that is minus 3. A single iron ion is electrically cancelling the 3 chlorides. So which means the iron has to be plus 3. The oxidation state of iron is changing from plus 2 to plus 3. This means that iron was plus 2 pehle, now it's plus 3, and that is a loss of 1 electron. So that is oxidation of iron to ions. It is the oxidation of iron to ions. Another example we have with us, for example, let's go. Maybe manganate, a very common example. MnO4 is turning into MnCl2 through any equation. I'm not talking about what are the reactants. It's not balanced. I'm just telling you that this is happening. So MnO4 had a minus charge on top of it, 1 minus, and now MnCl2 is a compound. I know this for sure that there are 4 oxygens, so minus 2 times 4, which means minus 8. What should be the oxidation state of the manganese atom so that the total is minus 1? I need the total to be minus 1. So what should be this manganese? What should it be? So it has to be plus 7 because plus 7 minus 8 has to be minus 1. So this manganese is plus 7 on the left hand side. When I look at the product side, there are 2 chlorides, minus 1 because chloride is minus 1, and there are 2 of them, so minus 2. The manganese is cancelling electrically. It is kind of becoming it plus 2, so that plus 2 minus 2 cancel out each other. So here it is plus 2. So manganese atom is changing from plus 7 to plus 2. It is decreasing. So decrease happens when you gain electrons. So from plus 7 to plus 2 oxidation state means gain of 5 electrons. So you can say the MnO4 minus ion is gaining electrons, which means it is getting reduced. So this whole idea is more useful for us when we are trying to balance the redox equations. Now, we are going to try the same thing that we did last time. We are going to add a page, insert blank page, and I'm going to try to add a blank page. Oh, it worked. So now I'm going to be talking about balancing a redox equation. We have 2 methods for balancing a redox equation. The first method we have is called the ion electron method. That is not a part of the AS level syllabus, but I will be teaching it eventually. And the second method is oxidation number method. Oxidation number method that I was trying to bring you towards. So let's begin. In the oxidation number method that I'm talking about right now, I'm going to pick a very common example. Let's say a common example would be, let's go. Let's suppose very simple that we begin with FeCl2 reacting with chlorine to give you FeCl3. So FeCl2 plus chlorine reacting to give you FeCl3. The oxidation number of iron is +2 on the left-hand side. It is +3 on the right-hand side when it becomes iron 3 chloride. So iron is changing from +2 to +3, which means it loses 1 electron. When I look at chlorine is changing from 0 oxidation state because it was an element in the beginning, and now as a compound it has to be -1. Each chlorine, I'm talking about each chlorine. There are 2 chlorines because Cl is not Cl, it's Cl2. There are 2 chlorine atoms, each changing from 0 to -1. So it's a change of one number, but 2 atoms are doing it because chlorine is a Cl2, right? It's not a single atom. So both atoms are changing from 0 to -1, which means gain 1 electron times 2. So there's a loss of 1 by iron, but there's a gain of 2 by chlorine. This is not balanced. So how do we balance it? The number of change in chlorine's oxidation state, which is -2, chlorine gains 1 times 2. So there's a gain of 2 electrons, and iron loses 1 electron. You can write the 1 with chlorine's molar ratio, and you can write a 2 as iron's molar ratio. The gain of 2 electrons because of chlorine becomes the mole ratio of iron, and the loss of 1 electron by iron becomes the mole ratio of chlorine. And as a result, what do we get? We get the next stage as F2FeCl2 plus single chlorine gives you FeCl3. Now the right side can be balanced by simple whole number method. So you have 2 irons, you get 2 over here. Now it's balanced. It is not only balanced atomically, it is also balanced on basis of the oxidation numbers. I'll give you more examples and you can try this one out. Let's pick this one. Sulfuric acid reacts with HBr to give you SO2, Br2, and H2O. One thing is for sure that hydrogen, oxygen atoms don't change their oxidation numbers. Let's pick sulfur because sulfur, chlorine, nitrogen, transition elements, they change their oxidation numbers a lot. This is a note we should know. Sulfur, nitrogen, chlorine, and transition elements change their oxidation number. Not just chlorine, but halogens. Halogen is written as X. Let's take one example. Sulfur is becoming SO2. From sulfuric acid is becoming SO2. What's the oxidation number of sulfur in H2SO4? So I know this, that oxygens are -8 because each is -2. Hydrogens are +2. +2 -8, -6. +2 and -8, -6. Sulfur has to be +6. So sulfur is +6 in H2SO4. When I talk about SO2, there are 2 oxygens, so -2 times 2, which is -4. Sulfur has to be +4. So sulfur is changing from +6 to +4, which means gains 2 electrons. One sulfur atom gains 2 electrons, that's it, gains 2 electrons. Let's look at bromine. The HBr has a bromine with -1 oxidation state, but when bromine, I look at bromine H like Br2, it's an element with 0 oxidation state. It is changing from an oxidation number of -1 to 0, so it loses 1 electron. The 1 of change in bromine's oxidation number becomes the mole ratio of H2SO4, and the 2 of sulfuric acid's change in oxidation number, this 2 comes here. The bromine's change in oxidation number becomes mole ratio for H2SO4. The sulfur's change in oxidation number becomes a mole ratio for bromide. Now, we get this equation written as H2SO4 plus 2HBr, and then you can balance the right-hand side on your own basis. So I have SO2, 2 Brs means Br2, H2SO4, H2O. Let's count this. We have 2 hydrogens here, 2 hydrogen here. So we write a double over here, which means 4 hydrogen atoms. When I look at oxygen, we have 4 oxygen atoms here. We have 2 oxygens in SO2, and we have 2 oxygen atoms in water. So that is again 4. And even when I talk about bromine, it's balanced. Let's take one more example, H2SO4, I2, sulfur, water. For example, sulfur we know is an oxidation number +6. And when it's pure sulfur, it's an element, it's becoming oxidation number 0. So each atom, I need to enhance my arrow. Sulfur gains 6 electrons. Each sulfur atom, one sulfur atom gains 6 electrons. When I look at iodide, it is changing from -1 to 0. So it loses 1 electron. The change in oxidation number of sulfur becomes the mole ratio for Hi. So I write a 6 over here. The change in iodide's oxidation number becomes a mole ratio for sulfuric acid. It becomes 1. I'm going to get single H2SO4 reacts with 6 times Hi, gives me I2S plus H2O. I can balance it later by using simple whole numbers. And that is going to be looking like 6I gives me 3I2. A single sulfur gives me single sulfur as atom. There is 6 hydrogen atoms in Hi and 2 hydrogen atoms in H2SO4, so total of 8. I'm going to write 4 water, so that's a total of 8 hydrogen atoms. When I count oxygen, there is 4 oxygen atoms in the left, and there is 4 times 1 oxygen atoms in water. So I'm going to get this balancing done by simple redox method. We have more examples. We'll do more past paper questions. In the next class, we'll do more practice, and then we'll jump on some MCQs. Stay tuned, guys. Thanks.